You guys see that? It's loading up. Okay, so we are gonna be extending our last week's lecture on matrices, and this time we're gonna be using what's known as the inverse method to solve for a system of equations. So inverse method. So actually, who's got a pen I can borrow? Got a pen I can borrow? Pen? Okay, the inverse method. Okay, so to do the inverse method, we've got the following equation first. So we've got x plus, I'm just going to leave it blank here, plus z is equal to 12. Then we've got 2x plus 2y plus z is equal to 8. And then we've got x plus y minus z is equal to the number 2. Okay, so we're going to use the inverse method to solve for this. This is basically when I convert this into a matrix equation. Okay, but before we do that, just a couple of checks. This is the most important check. It's just to make your unknown variables are aligned. So your x's are aligned, your y's are aligned. So notice this first equation doesn't actually have a y, but I've made a blank there just to show, illustrate that my y's are aligned. If there was a y, it would be aligned, and my z's are aligned. And second check is just to see if there's any equations you can simplify. None of these you can simplify. So we're going to create our first matrix, and this matrix is actually going to capture the coefficients here. Right? So coefficient of x is 1. Coefficient of 0, there's y here. So coefficient of y here is 0. Coefficient of z here is 1, and I'm going to close that matrix off. And I'll do the same here. 2, 2, 1. 1, 1, negative 1. Okay, this matrix I'm going to multiply with this other matrix, which will contain my unknown variables x, y, and z. And I'm following that order, x, y, and z. And I'm going to make this equals to this matrix is going to capture these answers here on the other side of the equal sign, 12, 8, and 2. Okay, so whilst you may feel the construction of these matrices may seem random, if we actually multiply these out, it would be the same as what we just got up here. So for example, if you remember how to multiply matrices, it's row 1, column 1. So let's do this. 1 times your first number in your row multiplied by first number in your column. So 1 times x is x, plus 0 times y is 0, plus 1 times z is equal to 12, 12. Right? And we can do the same. This equation, or this row multiplied by this column, would give us the second equation, and this row multiplied by this column will give us our third equation. Okay, so we want to solve for this matrix x, y, and z. If we solve for this, this will represent our answers for our unknown variables x, y, and z that would simultaneously satisfy this system of equations. Okay, so to do that, let's denote this in simple terms first. Let's call this first matrix matrix A, which is being multiplied to this second matrix. Let's call this matrix x, which is going to be equals to this third matrix. Let's call this matrix B. So that's your matrix B, this is matrix X, and this is your matrix A. Okay, so through transposition, they may have done this in your lectures. If you want to know how I've done this, do let me know at the end of the class. But through transposition, they solve for this to be x is equal to the inverse of A. So you're getting x by itself, so x is equal to the inverse of A multiplied by B. So to solve for x, what's your first job, I should say? You're going to find, or this bit, this is your inverse of A. Okay, and then you're going to multiply that with this one here. This is your matrix B. Okay, so our first job, we want to find the inverse of A. So to solve for the inverse of A, I'm going to denote it as A to the power minus 1. So that's just to say I'm finding the inverse of A. Okay. So how do we do that? We're going to create the A matrix. So we've got A already. So up here, I'm just going to replicate it. 1, 0, 1. And don't write anything here because I have to do something else here. 2, 2, 1, 1, 1, negative 1. I'm going to augment matrix A. So this is me augmenting. So I'm joining it with its identity. So the identity matrix is just 1s on the diagonal, everything else is 0. So since this is a 3 by 3, we've got 1s on the diagonal, everywhere else is 0. 1s on the diagonal, everywhere else is 0. Okay, now we're going to use Gauss-Jordan to solve for this. And how do we do that? Well, you may remember last week we had a problem looking like this, a smaller version, and we want to get 1s on the diagonal, everywhere else is 0, and we achieved that column by column. And once we got 1s on the diagonal, everything else is 0, all this represents our answer. Well, we're doing essentially the same thing, but now all of this, whatever is left over, represents our answer. Okay. So remember, when we try to get 1s on the diagonal, everything else is 0, we attack this matrix column by column, and we always begin where the number 1 should be. So looking at this, where should the first one be? We want 1s on the diagonal, everything else is 0. Where it should be is right at the top, right? So this is already a 1 for us. That's good. All other numbers in that column, we want to make it to 0. So that means we want to make this 2 to be a 0, and we want to make this 1 to be a 0. But eventually, we'll get to 1 eventually. Let's get to 2 first. So how do we change a number to, and I might just put it here, how do we change a number to a 0? You're going to use the anti method. Okay, the anti method. Okay, so let's do this together. What's the anti of positive 2? Anti positive 2 is negative 2. Now, this is what I'm going to essentially do to make this negative to 0. What's negative 2 plus 2? 0. Right, so how do we write that in words? Okay, this is the next question. What number from this column can I multiply to be equal to negative 2? And the answer to that question 100% of the time will always be the same. Go for the 1. You've got 2 1s here available. In this case, you can choose whichever one and that will work. So I'm going to make this 1 here negative 2. 1 times negative 2 is negative 2. Negative 2 plus 2 is 0. How do I write that in words? This 1 is in row 1. So I'm going to go row 1 multiplied by negative 2, and then I'm going to add it to this 2, which is in row 2. Plus row 2 is the new row 2. So I'm going to do all the workings, but I'm going to try to squeeze it in here as best as I can. Every element in row 1 multiplied by negative 2. So here we go. 1 times negative 2 is negative 2. 0 times negative 2 is 0. 1 times negative 2 is negative 2. 1 times negative 2 is negative 2. 0 times negative 2 is 0. And 0 times negative 2 is 0. Okay, so each one of these I'm going to add to old row 2 to form the new row 2. So here we go. Row 1 doesn't change here. So I'm just going to copy it. Row 2 is going to change. Everything here, I'm going to add to old row 2 to form the new row 2. So here we go. Negative 2 plus 2 is 0. That's what we wanted, so that's good. 0 plus 2 is 2. Negative 2 plus 1 is negative 1. Negative 2 plus 0 is negative 2. 0 plus 1 is 1, and 0 plus 0 is 0. Okay, that's now a 0, that's what I want. Now I'm going to get this 1. So remember, all other numbers in that column, you want to get to 0. So that means you want to get this 1 to a 0. So again, you can use the anti method. So let's do it. What's the anti of positive 1? Negative 1. What number can I easily multiply to be equal to negative 1? Always go for the 1. So you can, excuse me. So you can do this. This positive 1 multiplied by negative 1 plus this 1, and that will make it 0. Okay, that will definitely work, and that will always work. Or, and this will only sometimes be available to you, you can just minus rows. So I'm going to just go 1 minus 1 is 0, and that will work. So we're going to go row 1 minus row 3 is a new row 3. So row 1 minus row 3 is a new row 3. Okay, let's do this. 1 minus 1 is 0. 0 minus 1 is negative 1. 1 minus minus 1. Right? So 1 minus minus 1 is double negatives, so that becomes 2. 1 minus 0 is 1. 0 minus 0 is 0. And who can tell me what's 0 minus 1? I think I've already done it here, but I'll just emphasize it. What's 0 minus 1? Negative 1, right? So don't forget, 0 minus 1 is not just 1. 0 minus 1 is negative 1. Okay, that column is now done. You lock it into place. You move on to the next column and you repeat exactly the same steps. And the next step is you always go for the 1 first. So where should the next one be? Since you want 1s on the diagonal, the next one should be this number 2. Okay, so how do we change a number 2 to become a 1? To change a number to a 1, it's always the same. Divide by itself. You always divide by itself. Okay, in fact, these are the only 2 strategies you'll be utilizing. Okay, so what's 2 divided by 2? 1. How do we write that in words? This 2 is in row 2. So I'm going to go row 2 divided by 2 is the new row 2. Okay, so let's do this. Row 1 doesn't change, so I'm just going to replicate it. Row 2, everything divided by 2. So here we go. 0 divided by 2 is 0. 2 divided by 2 is 1. Negative 1 divided by 2 is negative 0.5. Negative 2 divided by 2 is negative 1. 1 divided by 2 is 0.5. And 0 divided by 2 is 0. Okay. Row 3 doesn't change here, so I'm just going to replicate it. Okay. All other numbers in that column, right, you want it to be equal to 0. Fortunately for us, that's already a 0. That's good. That means we want to change this negative 1 to a 0. So how do we change a number to a 0? Always the same. Anti method, right? Okay, so let's do this. What's the anti of negative 1? Positive 1. What number can I easily multiply to be equal to positive 1? Well, you could say in this column, there's already a positive 1 there. Right, so instead of trying to convert a number to a positive 1, it's already there. So I'm just going to go positive 1 plus negative 1 is 0. How do I write that in words? This positive 1 is in row 2. This negative 1 is in row 3. So I'm going to go something like this. Row 2 plus row 3 is a new row 3. Okay, so let's do this. Row 1 doesn't need to change. It's already the number I want it to be, so I'm just going to copy it. Row 2 is going to change. No, it doesn't need to change as well. Row 3, everything here divide by, row 3 is going to change by going row 2 plus row 3 is a new row 3. So let's do this. 0 plus 0 is 0. Notice my previous workings don't change. 1 plus negative 1 is 0. That's what I wanted. Negative 0.5 plus 2 is 1.5. Negative 1 plus 1 is 0. 0.5 plus 0 is 0.5. And 0 plus negative 1 is negative 1. Okay. That column, notice, is now done, right? You lock it into place, you move on to the next column, and again the same strategy applies. Always go for the next one. The next one should be, since you want 1s on the diagonal, the next one should be 1.5. How do I change a number to 1? Always the same. Don't deviate from the strategy because there's no other easy strategy. You just divide by itself. That's so easy, right? So 1.5 divided by 1.5 is 1. How do we write that in words? This 1.5 is row 3. So I'm going to go row 3 divided by 1.5 is the new row 3. Okay, so row 1 doesn't change here. I'm just going to replicate it. Row 2 doesn't change here. I'm just going to replicate it. Everything in row 3 divided by 1.5 is the new row 3. 0 divided by 1.5 is 0. Notice my previous workings don't change. 0 divided by 1.5 is 0. 1.5 divided by 1.5 is 1. That's what we wanted. 0 divided by 1.5 is 0. 0.5 divided by 1.5. So what's 0.5 divided by 1.5? Who can tell me? That's going to give you like something like 0.33, right? Let's see. Is there any rounding here? Okay, 0.33. So 0.5 divided by 1.5 is 0.33. And what else do we have here? Negative 1 divided by 1.5. So negative 1 divided by 1.5 is actually going to give you negative 0.67. So there's your negative 0.67. Okay, so throughout this whole thing, if you find using calculators through every step, do it, right? If you want to be consistent and make sure you're doing things correctly, by all means use a calculator for every step. Okay. All other elements in that column you want to change to 0. So we're going to change this one to a 0, and eventually we're going to change 1 to a 0. So I'm going to create a new matrix. Okay, so some of you may think, how do I know when to create a new matrix? This is basically it. Every time I change a number to 1, I create a new matrix, change that number to 1, everything is copied. Every time I change a number to a 0, I create a new matrix, change that number to 0, but I make sure all my other needs for changing a number to 0 is also done in that same matrix. So every time you change 0, you change everything to 0 in that same matrix. Every time you change the number to 1, which only happens once per column, you change that number to 1, everything else is copied. Don't know if that makes sense, but the more you do this, you'll probably start to recognize it. Okay, row 3 doesn't change, so I'm just going to replicate it. Okay, row 2, everything divided by, oh no, we're going to change this to 0. We actually haven't wrote it yet. I've skipped a line. Well, I didn't skip a line, but I kind of skipped a step. This is still okay though. How do we change this to 0? Let's use the anti method. Okay, what's the anti of negative 0.5? 0.5. What number can I easily multiply to be equal to positive 0.5? Always go for the 1. So just remember here the pro tip, whenever you have more than one to choose from, always go for the one with the most zeros. So this one has more zeros compared to this one which only has 1 0, right? Why do you want to go with the one with the most zeros? Because that would very unlikely affect your previous answers because you're just handling zeros. Okay, so I'm going to go make this one positive 0.5 and then I'm going to add it to this negative 0.5. So how do I write that in words? I just might do it here. Row 3, that's where this one is, multiplied by positive 0.5 plus this negative 0.5 is row 2. Is the new row 2. Okay, let's grab out some working out. Every number in row 3 multiplied by 0.5. So here goes. 0 times 0.5 is 0. 0 times 0.5 is 0. 1 times 0.5 is 0.5. 0 times 0.5 is 0. 0.33 times 0.5 is 0.17. And then negative 0.67 times 0.5, let's see if I can squeeze it here, is negative 0.5. Negative 0. Let's see if I can adjust that. Negative 0.335. Okay, so this is, just to be very clear, your negative 0.67 multiplied by 0.5. That's negative 0.335. Okay. Each one of these I'm going to add to old row 2 to form the new row 2, and I'm going to put it here. 0 plus 0 is 0. 0 plus 1 is 1. Notice my previous workings don't change. 0.5 plus 0.5 plus negative 0.5 is 0. That's what we wanted. 0 plus negative 1 is negative 1. 0.17 plus 0.5 is 0.67. And then negative 0.335 plus 0 is negative 0.335. Okay. One more to do and we're done, right? This number 1 here, we want to change to 0. So you can use the anti method again. What's the anti of positive 1? Negative 1. What number here can I multiply to be equal to negative 1? Always go for the 1. So you can make this 1 times negative 1 plus 1 is 0. That would definitely work. Or sometimes you can minus them. In this case you can. I can just go 1 minus 1 is 0. So how do we write that in words? This 1 is in row 1. So I'm going to go row 1 minus row 3 is the new row 1. Okay, so let's do this. Row 1 minus row 3 is the new row 1. 1 minus 0 is 1. 0 minus 0 is 0. Notice my previous workings don't change. 1 minus 1 is 0. And then we'll keep on going. 1 minus 0 is 1. 0 minus 0.33 is negative 0.33. And 0 minus 0.67. So just be careful here with double negatives. 0 minus minus. That's positive. Okay. You're done here. What does all this represent? All this represent your inverse of A. You've just found the inverse of A. Okay. Now, how do we solve for this? Remember, x is equal to the inverse of A multiplied by B. Right? So x is equal to the inverse of A multiplied by B. We know x to represent our unknown variables. What was our unknown variables? X, y, and z, which is equal to the inverse of A, which we've already solved. So I'm just going to write it out. Which I'm now going to multiply to matrix B. What was matrix B? Well, matrix B was just this one here, 12, 8, 2. Okay, how do we multiply matrices? Remember, this is the insides needs to be the same. So this is a 3 by 3. So this is what we learned last week, which we multiply by 3 by 1. Inside is the same, that's good. We're going to use the outside to construct what we expect. We expect 3 rows and 1 column. Okay, so I'm just going to set it up for you guys, and I'll get you guys to do the rest at home. So this is 3 rows, 1 column. Row 1, row 2, and row 3, and 1 column. Okay, so how do we do this? Let's do row 1, column 1 first. Where's row 1? See if I can get some pens. This is row 1 here, just up here. Where's column 1? This is column 1 here. So how do we multiply matrices? We're going to do a row by column. So here we go. First number in your row multiplied by first number in your column. 1 times 12. Plus second number in your row multiplied by second number in your column. Plus third number in your row multiplied by third number in your column. And then you evaluate that, right? So I'm going to let you guys do the rest at home, right? We're going to move on to the more important questions. This is important for your assignment because you actually have to use by hand solving for the inverse, right? So we've done that first key question. This part here we just did last week, right? So I'll let you guys cover that. Let's explore our application question. So here we go. Okay, so what we've got, we're doing question 1 here. Let's read this input-output table for this 3-sector economy. So here from the output side, we've got 3 industries: agriculture, industry, and services. Here we've got those 3 industries as well, as long as other demands, and these represent our input side. Okay, so how do I interpret these numbers? Let's interpret this 150 first. Going out of agriculture, 150, let's call this $1 million. $150 million out of agriculture is going into agriculture. Does that make sense? Let's keep reading. $225 million is going out of agriculture and going into the industry sector. $125 million from agriculture is going into the service sector. $100 million from your agriculture sector is going into other demands. What's other demands? It can be other sectors, smaller sectors, or it could be something entirely different. Right? So we just call them other demands as a general name. Let's say I want to know how much in total is coming out of agriculture. I would actually have to add up all these numbers, and that would give me total output of 600. Are we comfortable with interpreting those numbers? Right? And the rest are the same, right? Okay. So here, what does this table actually summarize for us? The internal demands between these industries in our economy, right? So these industries, in order for agriculture to produce stuff, it needs stuff from its own, it needs stuff from industry, and it needs stuff from services. Does that make sense? Or for example, I know these are very general headings, but for example, in order for the steel department to produce steel, what do they need from other industries? They need energy, they need water, they need, I don't know, what else? Materials, they need some sort of metals, right? So they need maybe the mining sector, right? So industries, in order for them to produce stuff, are reliant on other industries. This table summarizes that information for us. Okay, we've got some other words here to read. If the final demands from each sector, instead of saying final demands, I call this my external demand. I find that a little less confusing. External demand. So I'm just going to write it, external demand. If the final demand / external demand from each sector are 500 from agriculture, 550 from industry, and 300 from financial services, calculate the total output from each sector. Okay, let me give you the context of what the problem is asking us. Given these internal demands and given these external demands of these amounts, how much should each industry produce in order to satisfy not only the internal demands but the external demands? That's the problem. Okay, so to do this problem, the first thing that you have to recognize is that we're actually dealing with, let's start a new page here. We're actually dealing with what's known as the Leontief input-output model. Okay, so when you're dealing with this Lee and Tip input-output model, you are dealing with a general solution that looks as follows. X is equal to I minus M, the inverse multiplied by D. Okay, so let's denote some notations. What does X represent? This represents your unknown industry total amounts. This is in fact what we wanted to solve for, X. What does I represent? Your identity matrix. What does M represent? It's known as your technology matrix. And what does D represent? This represents your external demand. Your external / final, let's say, demand. Okay, so to solve for X, we're just going to actually follow this as it dictates to us. So we want to do I minus M, but we know I is just the identity matrix, right? So this is just ones on the diagonal, everything else is 0. We need M. How do we construct M? This is where we're going to have to do it first. So M, I'm just going to follow the same labels as our table. So M is labeled as agriculture, industry, and service. Then I got agriculture. Okay. Let's do this together. Okay. How much from A goes into A? Let's read the table. 150, right? But I'm going to write 150 as a proportion of, so I'm going to divide it by, as a proportion of total, let's make this a bit more focused, of total A. How much in total is coming out of A? 600. How much from A goes into I? 225? As a total of total I, how much is total coming out of I? 900, right? How much from A goes into S? 125. As a proportion of total S, how much in total is S producing, or how much is output from S? You just add up all these numbers, right? It's been added up for you, it's just 300. Okay, and we just keep it going. Let's do one more. How much from I goes into A? 210. Divide by total A, 600. So I think you guys get this pattern here. I'm just going to keep on doing this. Oh, sorry. And I'll just keep on going. That's 140, by the way. Okay. Now, let's evaluate this. Okay. So, M is equal to, I'm just going to evaluate this. So, for example, what's 150 divided by 600? That will just give you 0.25. And I'm just going to go 225 divided by 900 and so on, so on. So, we're just going to put these in. There's your M matrix. Okay, now we're going to actually follow the key steps here. What's the first step? We're going to go I minus M, right? So this is I minus M. What's your I matrix? It's your identity of your M, right? Since your minusing matrices, they need to be the same size. So since this is a 3 by 3, your I matrix is a 1, 0, 0, 0, 1, 0, 0, 0, 1. That's your I matrix. Minus your M matrix, which we've just done here. So I'm just going to repeat it. Okay, which is equals to. Okay, so I think I can squeeze it here. Let's have a look. Okay, so when you're minusing or adding matrix, it's pretty much the same. It's your first element minus its corresponding element. So 1 minus 0.25, we know that's just not negative, what am I doing? Positive 0.75. Okay, or 0 minus 0.25 is negative. I should have done this on another page. Actually, I will. This is, I think I'm just going to start a new page here. Okay, so I minus m, here we go. 1 minus 0.25 is 0.75. 0 minus 0.25 is negative 0.25. 0 minus 0.42 is negative 0.42. Right, and you just keep on going, right? So you just don't have to do it once, and if I feel you'll be masters at this. 0 minus 0.35 is negative 0.35. I think we get the jits, so I'm just going to keep on going here if you don't mind. Okay. That is I minus m done. What's the next stage? You're going to find, you found I minus m, you're now going to find the inverse of I minus m. Okay, how do you find the inverse of I minus m? Well, if you had to do this by hand, you augment this with its identity and solve it using Cauchy-Jordan. Exactly the same way we did with problem 1. Right? But for your assignment, we actually solve this using Excel. Okay, so we've done this kind of last week, so we're going to do it again. So again, these instructions are already on your assignment, so you don't have to memorize anything, but let's do it together. So first thing is I'm just going to enter that matrix. So we've got 0.75, negative 0.25, negative 0.42, negative 0.35, oopsie, that's here, negative 0.35, 0.72, negative 0.47, then we've got negative 0.28, 0.00, and 0.90. Okay, so that's your I minus m result. Now you're going to highlight the same dimension on another space. You're going to press equals, inverse, open bracket. You're going to highlight those numbers exactly in those dimensions. You're going to close that, and you're going to press, if this was Windows, Control Shift Enter. And that will be your answer. If this was Apple, you press something like Command Shift Enter or Control Shift Enter. So I'm just going to round these to 2 decimal places. So just to make it a bit more neater. Okay, there we are. There's the answer for my inverse of I minus m. That's the matrix I'm going to copy onto this .cap. So this will be equals to there's the inverse of I minus m. Okay, so what's its next step? Multiply that I minus m, you're done. Find the inverse, you're done. Multiply by d. Right, and you're done. Right, so the third step, or this is the second step here, sorry. And this is your third step here. You're going to go x is equal to I minus m, the inverse, which is up here, multiplied by d. Let's set this up. What's your x? Contains your unknown variable. So we put them in the same order, a, I, s, which is equal to the inverse of I minus m, which we found here. That's the inverse of I minus m, and then you're going to multiply that with d. What's your d matrix? That contains your numbers of your final or external demand. So if we go back to the question sheet, that's these numbers here. 500 from agriculture, right? 550 from industry and 300 from financial services, but you have to put them in that same order, right? So 500, 550, and 300. Okay. Now let's solve for this, right? Equals to, well, you can set this up. Let's put it up here. Let's, this is a 3 by 3, multiplied by 3 by 1. Insides are the same. Use the outside to construct what you expect. You expect 3 rows, 1 column. So you expect row 1, row 2, and row 3. And you expect 1 column. Okay, let's do the first one together. Row 1, column 1. This is row 1, this is column 1. 2.24 multiplied by 500. So if you were here last week's tutorial, that's good. You have some understanding of how to multiply. If you weren't, you got to catch up. Second number in row multiplied by second number in your column. Plus third number in your row multiplied by third number in your column. That answer would represent the total output that needs to come from agriculture. That's one answer. And then you do the rest for industry and services. Okay. I'm going to let you guys do the rest of this, but I do want to point out something related to your assignment. Your assignment, so we go back to your question sheet. This is a 3 by 3 input-output table, right? With 3 industries. In your assignment, you're actually going to be given 32 industries to do this, right? But you might think, how the hell am I going to do that? You've actually learned how you do it. You do pretty much the same way. So let's start from step 1. You're going to create your technology matrix. This will be 32 by 32, but the process is the same. Right? You're then going to go I minus M. This will be 32 by 32 minus a 32 by 32. Right? Same maths, just bigger. Then you're going to find the inverse of a 32 by 32. You'll be crazy to do this by hand. What are you going to do? You're going to use Excel. Then you're going to multiply that 32 by 32 by D. This would be a 32 by 1 matrix, right? That will be given to you, right? And then that's your answer. That's really just one part of the assignment, but it's a major part, right? Okay. I'm going to let you guys do the rest of this. If you have any questions, do let me know. I'm happy to hang around. Otherwise, this is really it for us. If you need help with creating groups, also let me know and we'll sort you out.